On this edition of MC Gen Chem, Energy and Chemical Reactions. In chemical reactions, reactants are on the left and products are on the right. If heat is given off in a reaction, then this can be called exothermic. If heat is needed for the reaction to proceed, then this can be called endothermic. Exothermic reactions can be portrayed using an energy diagram where the energy of products is lower than the energy of reactants. The total energy of the reaction can be determined by subtracting the energy of the products minus the energy of the reactants. If the energy is less than 0, then the reaction is exothermic. If the energy is greater than 0, then the reaction is endothermic. The corresponding energy diagram for an endothermic reaction has higher energy in the products than in the reactants. There are 4 important types of reactions. The first is a synthesis reaction. The general equation for this is A plus B goes to AB. The next type of reaction is a decomposition reaction. The general equation for this is AB goes to A plus B. Next is a single displacement reaction. The general equation for this is A plus BC goes to AC plus B. Lastly is a double replacement reaction. The general equation for this is AB plus CD goes to AD plus CB. One aspect of chemical equations is knowing how to write the correct chemical formula. For example, let's do calcium chloride. Begin by writing your separate ions for your compound. Calcium will be Ca2+, and chloride will be Cl-1. The charges will transfer to each compound when combined, leaving you with CaCl2. With chemical equations, it is also important to know how to balance an equation. It is important to know how to balance an equation due to the law of conservation of mass, meaning that what you begin with in the reaction must be present at the end of the reaction. For example, let's balance H2 plus N2, reacting to form NH3. Since there are 2 nitrogens, place a 2 in front of the NH3 in order to balance the amount of nitrogens. Since there is a 2 in front of NH3, this means that there are 6 hydrogens on the product side, which means you must place a 3 in front of the H2 in order to account for all of the hydrogens.